Good afternoon. Today we are going to see the shape function by using Lagrange polynomials. So now we have shape functions using Lagrange method, and in this we have formula that is Lk, k that is the node number at which we are going to find out the shape function, equal to pi m is equal to 1 to n. So whatever number of nodes we have, if we have 2 nodes, then we have n equal to 2. If we have 3 nodes, then we have n equal to 3. Now, but here that is most important, m is not equal to k. That means at whichever node we are going to find out the value of shape function, this you can say as nk also. But as this is by using Lagrange, so he has given this symbol as L suffix k. So this is most important. We are not going to take value of m is equal to k. So we have x minus xm divided by xk minus xm. So in numerator also we are not going to take xk, and in denominator also we are not going to take xk. So m is not equal to k. So now from this we are going to get Lk is equal to. So now let us, we have n number of nodes. So we have first x minus x1, then we have x minus x2. Then we are going to consider x minus k minus 1. So this is x. So we have first term x only, and value of m we are going to change from 1 to n, but m is not equal to k. Now we have k, x, k minus 1, but we do not have x minus xk. And therefore, we are going to be next term k plus 1. So xk we are not using, and then we have x minus xn. Similarly, we have same terms below, only change we have xk minus. That means we have first term xk minus x1, then we have xk minus x2, then we have xk minus 1, xk minus xk plus 1 upon xk minus xn. Means in numerator, we have first term same, which is x, and in denominator we have only x is replaced by xk, otherwise terms we have same. And by using this we are going to find out shape function. Now we will consider one dimensional element. When we will talk about one dimensional element, so minimum number of nodes we require for one dimensional element, that is 2 only. So 2 noded bar element we will consider in first video. In second video we will go for 3 noded bar element, and then we can have ahead. So we have take n is equal to 2. So we have taking 2 nodes. So we have node 1, we have this is node 1, and we have this as node 2, and we have coordinates of these nodes are x1, x2. Now when k is equal to 1, means we are going to find out shape function for 1. So now shape function for node 1. So we have substituted k is equal to 1. Now we know formula. We have formula that is x minus xk, x minus xm divided by x divided by xk minus xm. So we have these values. Now we have to put xm. Now here we have 2 nodes. So we are finding for first node. So my value of m is equal to 1. So we are not going to use x1 anywhere. We are going to use x minus x2. And below we have m is 1. So x1 minus x2. So we are L1 is equal to x minus x2 upon x1 minus x2. So x minus xm, m is 1, x minus xm, and we have k is 1, not m, sorry. So we have k is equal to 1, and then we cannot put m equal to 1. and therefore we have x minus x2, and below we have xk minus xm, and therefore we have x1 minus x2. Now this is general formula to find out shape function at 1. We are going to find out variation of this shape function. Now we will put value of x equal to x1. So we will get value of shape function at node 1, and then we will we will put the value of x equal to x2, and then we will get value of shape function at node 2, and then we are going to get variation of shape function along this element. So whatever now we are going to plot, that is only for shape function at 1. So now we have x2 minus x upon x2 minus x1. So we have just changed it. We have taken minus common from numerator. We have taken minus common for denominator. So it becomes x2 minus x, and this becomes x2 minus x1. So we have, this will be n1. And then we will substitute at node 1, we have x equal to x1. So if we will put x equal to x1, so we have value of n1, that will be 1, because in that case we are going to get x2 minus x1. At node 1 we have x equal to x1, so x2 minus x1 numerator, x2 minus x1 denominator. So we are going to get value of n1 is 1. Now we will plot it 1. Now we have at node 2, we have value of x equal to x2. And if I will put x equal to x2, so it becomes x2 minus x2, it becomes 0. So my value of n1 is 0. So if you will go for variation of n1, so we have value at node 1, that is 1, and value at node 2, we have 0. So now we have this value 0, and then we have going to get this variation of n1. Now we will go to when k is equal to 2, means we are going to find out shape function at 2. What does it mean? What does it shows? Variation of n1 means value of n1 at any point. If I will consider this some point p, then we have value of shape function at this will be this value. So if you have to find out value of any displacement at this point, then knowing displacement at 1 and displacement at 2, we can find displacement at p, because displacement at p is a function of displacement at 1 and displacement at 2, and that function, that shape function we are using. So shape function into displacement at 1 plus shape function into displacement at 2, that will give us displacement at p. Now we have when k is equal to 2, so we have x1 x2, then we have n1 is equal to, now what will be formula? Now try to understand this. What is formula? So that we have already seen, we have formula for Lk, which is equal to x minus xm upon xk minus xm. And here m is not equal to k. And when we will say k is 2, so we are not using x2 for xm, but xk is x2. We have k is equal to 2. And therefore we will get it as x minus x1 and x2 minus x1. So you can see this x minus x1, x1 minus x2. And now we will put values. We have at node 1 x equal to x1. So if I will put x equal to x1 in node 1, so it becomes x1 minus x1, so 0. So my value of n2 at 1 is 0. And at node 2 we have x equal to x2. So if I will put x equal to x2, we have this value, sorry, this is xk, k is 2, so we have this value x2 minus x1. We have x2 minus x1. So I will write it is x minus x1 divided by x2 minus x1, because we have xk minus xm and k is 2, so it is x2 minus x1. And when we have at node 2 x equal to x2, so it becomes x2 minus x1 upon x2 minus x1, this value will be 1. And then you can have variation of n2. We have one value at 2, we have 0 at 1, and then we have, this is variation of n2. So similarly here at node P, if you are going to find the value of n2, then we have this value will be in this place. And therefore, displacement at P is this value into displacement at 1 plus this value into displacement at 2 gives you displacement at P. So shape functions we are using to find displacement at any other point. So now we will stop here only. So thank you. So for node, 3 nodes for bar element, that we will see in the next lecture. So thank you.